I'm Avery Layton, and this is my final project for my hazards class with Dr. Nick. My root cause analysis is going to be over the New York City steam pipe explosion that happened July 18th, 2007. And before I get into this, I'm just going to give a little backstory about why New York City has the steam pipe system. The steam pipes were put into place in the early 1920s, and they were put in there to decrease the amount of energy used in the taller buildings that were being built at that time. The steam pipe system allowed for heat to rise up to these taller buildings and the energy without anything having to be in place. So I'm going to show a video of the explosion itself, just a real quick snippet video, and then I'll get into the discussion. So while this was rising, I just wanted to add in here that this reached over 1,000 feet up in the air, 300 meters. Whenever this was going on, there was a tow truck that was around a block away. It drug it up in the air 12 feet, dropped it back down, and it created this 32 by 32 crater. So that also was a pushback on people responding to the event as well. I just wanted to add that in there, and all right. Okay, so the problem with this system was it was put into place during the 1920s. This happened in 2007, the catastrophe. Over the years, the corrosion of the pipes, they were made out of cast iron, and although they did hold up, they still had a lot of corrosion and rust on them. Then whenever these pipes would have a problem, the Con Edison, the company that took care of all these pipes and ran all of it, they would go in with a sealant and fix it whenever a problem was occurring. And then there was low monitoring on the water levels from the city in the underground level where all the pipes were at. After a heavy rainfall the morning that the catastrophe happened, the water began flooding that specific area, which was Lexington Avenue and 41st Street, that junction right there, that manhole. That system consisted of steam, and then that began to condensate. So when the water meets the steam, it creates condensate, and throughout these systems, they're going to have these traps that's going to trap that, and then that's how the system works. The condensate traps were activated to catch anything that would lead to potential explosion caused from the pressure that was mixing between them. So problem continued. Although the pipes were almost 100 years old, the design was tolerant to city codes. So that wasn't the exact problem of why this happened. The condensate traps had been blocked by the resin left by the sealant applications done in the previous pipes. The sealant had been going on for about 4 decades at least. The blockage made it where the condensate traps were ineffective, and once it filled enough with the water from the rainfall, so with it being ineffective, it was unable to send the data back to the generating station that would then shut these off. Overall, resulting stress from the old pipes from the water hammer's internal pressure and unbalanced pressure forces must exceed the strength of the pipe, and unfortunately, it just did not. So with water hammer, I also have not mentioned the way that this happens is the steam is trying to go through the pipes, the water is going up, and then that's when the condensate would happen. The pressure is going to go back and forth of the water in the pipe, and it's going to be too much, and then that's going to create the... So right here, the flanges, I have a picture of this. This is going to be the street. This is going to be the manhole. If you go down right here, this is how they were first initially put in place. So as you can imagine, just like this, if there was ever a problem, they could go in, fix one of the sides, and then it would be perfect. Over time, with modern technology, they thought by welding them more so like this, that it would help, and unfortunately, it was weaker whenever there was more pressure involved. So the way the system should have worked is almost as it was designed to, but with more controls, sensors, and human inspections. It lacked. The steam should have been able to flow properly through this piping system, and monitored through the pipes at a constant PSI, which is 150 to 170. Once the water was found underground, no matter what it was from, in this situation, the rainfall, there should have been a release to cause that buildup, more of a release because they were unaware. If this was the case, the system should have been built to shut off and the water should have subsided. Even if the water was still at a presence, the condensate traps are installed specifically to create a way for an area for it to go. And it couldn't mess with the steam. This sealant also that was used should have been a proper material that would not have caused the buildup over time of that resin, preventing the blockage on the pipes and then the condensate traps themselves. Okay, so my root cause analysis. The immediate cause that I'm going to point out is going to be the steam pipe rupture, obviously from the pressure, and then inducing a water hammer, and then the thermal within the main pipe under Lexington and 41st Street. The contributing factors that are going to go along with this are the older pipes and the city infrastructure. Like I've said, it was almost 100 years old since they had even thought about changing anything. The environmental factor of the heavy rainfall that morning of, they were unaware of how much rain actually was sitting under there with those pipes. No inspections or prevention had been taken until something bad had happened. And then the block traps from the condensate. And then the root cause was the condensate buildup and then the temperature change caused by poor drainage system from the water. The piping system led to pressure rupture of the steam mixing with that cold water that had just been sitting there. Description of all failures. So the cast iron pipes, like I've said, they were old. Although they held up, there was probably more that they could have done to change that. The flanges were interchanged throughout the past 4 decades, and some were not. So another thing I want to add in here is between 2005 and 2007, this specific manhole that they were going in and changing and dealing with the sealant issues with had happened 10 times during just those 2 years. The elevation of the pipes that they thought was going to help the flow of it, that and bend to trap the water. Condensate traps were not working because of the water level. New York City was not inspecting the piping system frequently, and neither was the company, Con Edison. Sensors are what sent the data to the generating station, and because those sensors and the traps were ineffective, they were not able to shut everything off. And then the sealant resin left behind over time had caused the condensate traps to become clogged. All right, for conclusion, if the steam pipe systems would have been frequently checked instead of until something happens, it would have been known that the water was in this specific area underground, and it would have been hard. It would have had not a hard time draining. If the systems were not so aged, they might have been able to hold the pressure caused from the condensate, along with a different type of sensor communication to the generating system. My recommendations were they had a very thought out plan, and I really think it could have worked if they took care of the system properly. But frequent inspections definitely needed to be done. A sealant product that is not going to cause that resin to clog the condensate traps and the flow of the steam. Enhanced monitoring through the city and the company itself. City upgrades with their infrastructure that city is always changing, and documenting any previous leakage from protection and prevention. Therefore, do something before something happens. And I want to thank you.